How does a machine learn to recognize a cat? Not by being told, look for whiskers. It learns the same way you did, from millions of examples. GPT-4 has 1.76 trillion parameters doing exactly this. Let's understand how. A neuron is just math. Take some inputs, x1, x2, x3. Multiply each by a weight. Add a bias. Push it through an activation function. That's it. That's a neuron. The formula, y equals sigma of the sum of wi times xi plus b. The bias b shifts the threshold. It's what lets a neuron fire even when all inputs are zero. The activation function sigma, like sigmoid or ReLU, adds the nonlinearity that makes deep networks powerful. Now stack thousands of neurons in layers. The first layer sees raw pixels. The second layer learns edges. The third, shapes. The final layer makes the decision, cat or dog. This is a neural network. A signal enters the input layer, gets transformed at every layer, and exits as a prediction. For reference, ResNet 50, a famous image classifier, has 50 layers and 25 million parameters. The input comes in strong and gets scaled down by its weight. The hidden neuron activates, producing a signal a little above half. That signal moves forward, gets adjusted again, and settles at just over 60%. So the network is about 60% confident that this is a cat. But we know it is 100%. And this is where learning begins. We measure the mistake using something called mean squared error. In this case, the model was off by about 0.38, and that gives an error of roughly 0.14. Imagine the loss as a landscape, a valley. Every combination of weights gives a different height. We want to slide down to the bottom, minimum loss. The question is, which direction do we step? The answer is backpropagation. Using the chain rule from calculus, we measure how much each weight contributed to the error. We pass those gradients backward through the network, layer by layer. Then we adjust each weight slightly in the opposite direction of the error. The size of that step is controlled by the learning rate, typically 0.001. If it's too high, you overshoot the minimum. Too low, you train for weeks. Numerically, weight 0.5 becomes 0.5 minus 0.001 times 3.2 equals 0.4968. This happens for every single weight, millions of times per batch. Each full pass through your training data is called an epoch. Watch the loss curve. It drops fast at first, then flattens. Early on, the network is confused. By around epoch 50, it begins to converge. Near 90, progress slows and plateaus. Training a ResNet on ImageNet can take weeks, which is why pre-trained models exist. One key detail: without activation functions, no matter how many layers you add, the network becomes just one linear transformation. ReLU keeps positives and drops negatives. Sigmoid squeezes values between 0 and 1. TAN centers them between -1 and 1. As training goes on, watch the validation loss. Training loss keeps falling, but validation starts rising. That's overfitting. The model memorizes instead of learning. To fix it, dropout turns off neurons, L2 shrinks large weights, and more data helps. In 3 minutes, you've learned how neurons and weights work, how predictions are made, how error is measured, how gradients update the network, and why overfitting can break real models. Subscribe so you don't miss what's coming next.